Take a look down at line 7. The command to create a delegation set is new-R53 reusable delegation set. Now the caller reference parameter here is not specific to Route 53, but it must specify a unique string. The get-random commandlet there just generates a random number. The purpose of the caller reference is to uniquely identify the request to create a delegation set. This lets us retry the request if it fails, which it should not. I've actually never had it fail. So let's go ahead and run this. I'll hit F8 to run it. And now let's go ahead and jump down to line 8 and we'll run get-R53 reusable delegation set list. AWS returns the identification of the delegation set, the caller reference, which is just that random number that PowerShell generated, and the thing we're most interested in, the list of name servers. Now let's take a look at these in a cleaner format. Please go down to line 11 and run that. And there we go. There's our list of name servers. Now we can now take this list of name servers and associate it with up to 100 hosted zones. We're dealing with just one domain name for now, so next we're going to create just one public hosted zone, but this time we're going to associate this delegation set with that zone. And here's how we'll do it. Scroll down to line 14 right here. Now the first thing we're going to do is grab the delegation set ID and store it in a variable. Now jump down to line 17. Here we set the zone name variable equal to the name of the zone that we want to create, which in my case is BenPiper.host. Now be sure to change this to reflect your domain name. Notice also that I have a trailing dot at the end, so it reads BenPiper.host. The trailing dot at the end is actually optional, but I do like to put it when dealing with a lesser known top level domain like .host, just so that it's obvious that host is actually the top level domain. You, of course, are free to leave off the trailing dot if you want to. Functionally, it makes no difference. It's purely cosmetic. I'll go ahead and run this. Now let's scroll down to line 20. And finally here, we create the hosted zone and save the results as a variable called zone. I'll execute this. And that's it. Next, let's take a look at the zone properties just to verify that everything looks good. Go down to line 23. And we'll run this just to view the properties of the zone we created. We've got the name, BenPiper.host, and there are two resource records sets, which of course are the SOA and name server records. Let's just take a look at these two record sets again, just to refresh your memory. To do that, I'm actually going to use NSLOOKUP. Let's go down to line 26. Now the first thing we're going to do is grab the name of the first name server in the delegation set and store it in a variable named first_ns. Let's take a look at the name of the first name server. And it is ns-806.aws.dns-36.net. Now, these are some rather cumbersome names. Now what we want to do now is query this name server for all resource records under the zone BenPiper.host. Let's jump down to line 28. Now look at the NSLOOKUP command here. The -type equals any flag causes NSLOOKUP to ask for all records. The $zone name variable tells NSLOOKUP the name of the zone we're interested in, which again is BenPiper.host, and the $first_ns variable tells NSLOOKUP which name server to query. And that of course is the first name server in the delegation set. Let's go ahead and run this. All right, awesome. The name server has returned 4 name server or NS records, which as you can see are the exact same name servers in the delegation set. Notice, however, that they are not in the same order. They actually look pretty random. Now take a look at the next record down. This is the start of authority or SOA record. Again, it specifies the primary name server. You recognize that. It's the first name server in the delegation set. The primary name server is, just as the name suggests, the name server that Route 53 originally stores the zone records on. It's where the zone records start out, hence the term start of authority or SOA. The name server and SOA records get started here first, and then those changes propagate to the other 3 servers up here. Now that propagation generally takes less than a minute, but it can take several minutes, And that is why I wanted to query the primary name server, because I know that it will always have the latest records for the zone. Okay, so far, so good. Our zone is set up correctly on the Route 53 side, and we have the set of name servers hosting the zone. Next, we need to tell the registrar of the domain about these name servers.